Okay, friends, today's topic is 3D geometry. So we have 30 questions with us. So we try to solve all the questions so that by solving questions we may get deeper understanding into the concepts of 3D geometry. ಸೊ ನಮ್ಮ ಹತ್ರ 30 ಕ್ವಶನ್ಸ್ ಇದೆ. ನಾವೀಗ ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡುವ. ನಿಮ್ಮ ಹತ್ರ ಕೂಡ ಅದು ಆಲ್ರೆಡಿ ಇದೆ. ಸೊ ಒಂದೊಂದೇ ಕ್ವಶನನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋದಾಗೆ ನಾವು ಈ 3D ಜಾಮೆಟ್ರಿಯ ಏನು ಅದರ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಉಂಟು ಅದನ್ನು ಅರ್ಥ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಟ್ರೈ ಮಾಡ್ತೇವೆ. ಸರಿ, ಮೊದಲನೇ ಕ್ವಶನ್, ದ ರಿಫ್ಲೆಕ್ಷನ್ ಆಫ್ ದ ಪಾಯಿಂಟ್ ಆಲ್ಫಾ ಬೀಟಾ ಗಾಮಾ in the xy plane. So what is the answer? So just consider your z-axis, y-axis and x-axis and alpha beta gamma. Alpha beta gamma is a point in the space. So its reflection on xy plane. So this is our xy plane. So its reflection must be in the other side of xy plane. So you are moving just downwards or along the z-axis. So no movement along x-axis or the y-axis. So clearly alpha beta remains same. And gamma, exactly it is on negative z-axis. So alpha beta minus gamma is the reflection of alpha beta gamma in the xy plane. So clearly our answer is alpha beta minus. So question number 2, the distance of the point alpha beta gamma from the y-axis. So this is also similar to the previous one. So let us have x-axis, y-axis and z-axis. So distance of the point from the y-axis, that is alpha beta gamma is a point alpha beta gamma, and its distance from y-axis. So let's consider, so this has the distance d from the y-axis. So if you drop a perpendicular from the point alpha beta gamma, so clearly these are the distances from x-axis and y-axis. So what is d? So clearly here you are having 90-degree angle. So once you get 90-degree angle using Pythagoras theorem, you can find the d value d. So whereas this distance is nothing but beta, and this distance is nothing but alpha. Sorry, this is beta and this is alpha. So what is this distance? This is our distance along z-axis, that is gamma. So clearly alpha square plus gamma square gives us our d square. So value of d is alpha square plus gamma square. So root of that, so the option C is the right answer. So D option is not visible. So our answer is C. So coming to third question, the equation of the line parallel to 2I plus j plus 3k and passes through the point 5 minus 2 and 4. So it's a direct question. You know, a vector B which is parallel to the line, that equals to 2I plus j and 3k, and we have a point that is 5 minus 2 and 4. So equation of a line, we have x minus x1 by the direction ratio, that is I component equals to y minus y1 by b equals to z minus z1 by c. So you replace x1, y1, z1 by the point 5 minus 2 plus 4. So clearly it is x minus 5 here, first option, x minus 5, second option is there, but y minus y1, y minus minus of minus 2, that is y plus 2, that is here first option, and last one z minus 4, z minus 4. So what are the denominators? So that is I, j, k components of parallel vector, that is 2, 1 and 3. So 2, 1 and 3, 2, 1, 3. So that is option A is the right answer. That is equation of plane which is parallel to 2i plus j plus 3k and passing through the point 5, minus 2 and 4. So fourth question, the intercept made by the plane 2x minus 3y plus 5z minus 4 equals to 0. So this is also a direct question. So you know x by a plus y by b plus z by c equals to 1. That is intercept form of the equation of the plane, where a, b, c are the intercepts made by the plane with x, y and z axis. So now you consider this equation, given equation 2x minus 3y plus 5z, and you write it as equals to 4 and divide throughout by 4. So we are getting 2 by 4 x minus 3y by 4 and plus 5z by 4 equals to 1. So right hand side we got 1, and in left hand side x component, that is x by a is the x-intercept, clearly x by 4 by 2, that is x by 4 by 2, 4 by 2 in the denominator, it is exactly equal to 2. So we have 3 options, 2 in the first place. And what about b? That is minus 4 by 3, minus 4 by 3 in the denominator, and here you are getting 4 by 5. So these are the x-intercepts. Clearly the first option is the right option. So 4 by 2 and minus 4 by 3 and 4 by 5 are the intercept made by the line, that is by plane in 3 coordinate axes. Plane. So question number 5. The plane 2x minus 3y plus 6z plus 7 equals to 0 makes an angle sine inverse alpha with x-axis. Then what is the value of alpha? So plane is making angle sine inverse alpha with x-axis. So clearly theta equals to angle made by equals to sine inverse of alpha. So we have a formula, equation of plane. So angle made by plane and the line. So angle, if it is theta, it is given by the parallel vector and the perpendicular vector to the plane and a vector which is parallel to x-axis. So that is plane. So 2x minus 3y plus 6z plus 7 equal to 0 is the plane. So normal vector is nothing but the coefficients of x and y and z. So that is 2y minus 3j plus 6k is the vector which is normal to the plane. And what is the vector which is parallel to x-axis? So that is nothing but our I. So angle sine of alpha, alpha must be equals to, that is n vector dot a parallel vector divided by magnitude of n vector and magnitude of vector b. So clearly I simply write it as its coordinates. So I write equals to, that is 2 minus 3 comma 6 dot product with 1 0 0, that is direction cosines of x-axis divided by square root of magnitude of first vector n vector, that is 2 square 4 and minus 3 square 9 and 6 square, that is 36, and this product is nothing but 2 into 1, that is 2 divided by 36 plus 4 49, root of 49 is divided by 2 divided by 7 is the sine in our value of alpha, where theta is sine inverse alpha, that is angle, and value of alpha is first one 2 by 7. So question number 6. The distance of the point -2, 4, -5 from the line x plus 3 by 3 equals to 5, y minus 4 by 5 and z plus 8 by 6. So distance of the point from the line. So consider the point that is -2, 4, -5 and the line. So distance is nothing but the perpendicular distance and the line is x plus 3. So it is the line x plus 3 by 3 minus y minus 4 by 5 and z plus 8. So now you consider to find the distance, that is perpendicular distance from -2, 4, -5. So distance, to find the distance you have to find the foot of the perpendicular from that point. So just consider the general point on the line. So using this equation, equating it to lambda, you are getting first quadrant, x quadrant as 3 lambda minus 3, comma, and y coordinate is 5 lambda plus 4, comma, next one 6 lambda minus 8. So these are 3 points on the line, or general point on the line. So we consider it as a foot of the perpendicular. So what are the direction cosines of the line? That we got 3, 5 and 6. So dr, or direction ratios, drs of line L, so I take drs of L, it is 3, 5 and 6. What are drs of this perpendicular line? So I consider it a point P and I write it as M. So drs of PM. So that is nothing but to get the difference M and P. So that is different 3 lambda minus 3 minus 2, that is 3 lambda minus 3 minus of minus 2, that is plus 2, and next one 5 lambda plus 4 minus 4, that is 5 lambda plus 4 minus 4, you are getting 5 lambda itself, and 6 lambda minus 8 minus of minus 5, that is plus 5. So clearly the drs of perpendicular line is 3 lambda minus 1, comma 5 lambda and 6 lambda, and that is minus 3. So you got, now you just take out the drs of the line and drs of the perpendicular line, that is distance line. So they are perpendicular to each other, so we know the dot product is 0. So 3 into 3 lambda minus 1 plus 5 into 5 lambda and 6 into 6 lambda minus 3 must be equal to 0. So this is the relation to find the value of lambda. So multiply 9 lambda minus 3 plus 25 lambda and 36 lambda, and that is minus 18 equals to 0. So 36, 25, that is 50 and 61, 70 lambda. And you get 18 and minus 3, that is 21. Clearly lambda is equals to 0. So that is 21 by 70. So that is, you are taking it out, 7 3s are and 10. So you got lambda equals to 3 by 10. So you just substitute in the drs of PM, that you are getting direction ratios of perpendicular PM, that is 3 lambda minus 1. So using this, that is 3 into 3 by 10 minus 1. So that is first term, and 5 lambda, that is 5 into 3 by 10, and lastly we are getting 6 lambda minus 3, that is 6 into 3 by 10 and minus 3. So clearly it is 9 by 10 and it becomes 1 by 10, comma 15 by 10, 15 by 10, and here 18. So 6 into 3 by 10, that is 18. You are getting 18 by 10 minus 3. So it is 30. So 30 minus 18, you are getting 2, and it is 2 minus 1, 12. So that is minus 12. So I write it here 1 by 10 and 5 by 10, and it is a minus 12 by 10. Clearly these are direction ratios of this perpendicular line. So what is the distance? So vector is nothing but S vector 1 by 10i and 5 by 10j and minus 12 by 10. So just find the magnitude of this PM, it gives us the distance. So clearly it is square root of distance is nothing but the magnitude of that vector, that is 1 by 10 whole square and 5 by 10 whole square and plus 12 by 10 minus 12 by 10 or 12 by 10 whole square. So clearly 1 by 10 is the option, 10 square, 10 square, 10 square. So 1 by 10 is there, so it is fourth option, and 1 square and 5 square and 12 square, it comes to be 370. So right answer is D, that is perpendicular distance from the point to the line. Joining points 2, 2, 1 and 5, 1, minus 2 is 4, then Z coordinate of the point is. So let's consider 2 points, that is 5, 1, minus 2 and 2, 2, 1. Now you consider it divides in the ratio k is to 1. So k into 2, so x coordinate must be equals to k into 2, so that is 2k, plus 1 into 5, that is 5, divided by k plus 1, and it is given that it is equals to 4. So we have 2k plus 5 equals to 4k plus 4. So 4k you are getting 2k and 4 minus 1, 1. Okay. So question number 7. The x coordinate of the point on the line joining 2, 2, 1 and 5, 1, minus 2, 1 is given it as 4. So x coordinate is given which is equals to 4. That is, this x coordinate is 4. So point is 2, 2, 1 and 5, 1, minus 2. So if you take it as in the ratio k is to 1, then 5 into k must be equals to 5 into k and 1 into 2, 2 divided by k plus 1 must be equals to 4, or 5k plus 2 equals to 4k plus 4. So clearly it is k equals to 4 minus 2, k equal to 2. Now they ask what is z coordinate of the point. So z coordinate of the point is again same, k into minus 2, k into minus 2 plus 1 into 1, that is 1 divided by k plus 1. So k into minus 2 and 1 into 1, that is our z coordinate, and z equal to k. So now you replace k by 2, that is 2 into minus plus 1 by 2 plus 1. So that is minus 4 plus 1, that is minus 3. Divided by 3, it comes to be minus 1. The answer is option D. So question number 8. The plane meets all the coordinate axes with centroid a, b, c. So plane meets all the axes with centroid a, b, c. So what is the plane? So you know x by a plus y by b plus z by c equals to 1 is the equation of the plane where ABC are x intersection and x intercept and y intercept and z intercept. Now they say the plane meets all the coordinates with centroid ABC, not intercepts, it is ABC as centroid. So what is the centroid of the triangle? So if ABC is the centroid of the triangle, if ABC is centroid of the triangle, so it must be x1 plus x2 plus x3 divided by 3. So this way you know the formula for centroid or x coordinate of the centroid of the triangle. So what are the coordinates of intercept made by the plane? So that is in x coordinate, so in the x-axis it is a 0 0, and in y-axis it is 0 b 0, and in z-axis it is 0 0 c. So exactly if ABC 0 a 0 0 0 b 0 and 0 0 c are the coordinates of the triangle, then what is the centroid? So that is 0 a plus 0, that is clearly a by 3, and 0 b 0, that is all x2 y coordinates, that is also b by 3, and the z coordinate is 0 0 and c, that is also c by 3. So clearly if a intercept is a, b and c, then centroid of the triangle is a by 3, b by 3 and c by 3. So clearly if ABC is the centroid, so what are the coordinates or intercept of? Clearly the intercepts are 3a and 3b and 3c are the intercepts. So if AB is 3a, 3b, 3c are intercepts. So if 3a, 3b, 3c are the intercepts, what is the equation? So just replace a, b, c by 3a, 3b, 3c. So you are getting the same equation, x by a, y by a, z by c, and 3 is the common term which comes to the right hand side. So clearly x by a, y by b and z by c equals to 3 is the correct option or equation of the plane. So question number 9. The coordinate of the perpendicular drawn from the point 2, 5, 7 on x-axis. So just consider the z-axis, y-axis and x-axis and z-axis. So coordinate of the point on x-axis, the point is here, and that is 2, 5 and 7. So if you draw a perpendicular on x-axis, what are the coordinates? Clearly, so perpendicular to xy plane, and this is the line, and this is the line on xy plane. So clearly, what are the coordinates? So all the points that is coordinate, that is y coordinate 0 and z coordinate 0. So what is the x coordinate of the foot of the point or line from 2, 5, 7 is exactly 2. So that is value along x-axis. So coordinate of the perpendicular drawn from the line on x-axis is 2, 0, 0 is the correct option. So question number 10. The direction cosines of the line 2 minus x by 2 equals to 3 minus y by 3 equals to 1 by z are. So direction cosines of the line. So direction cosines of the line are nothing but direction cosines of vector which is parallel to line. So what is the vector parallel to line? So that is 2i plus 3j plus 1 is the direction cosines of vector parallel to the line. So what are direction vector parallel to the line? So what are the direction cosines of this vector? So that is clearly 2 divided by root of 2 square plus 3 square plus 1 square, same way, divided by root of same value and 1 divided by root of same value. So 2 square is 4, 9 and 1, so 10, that is 14, root 14. So 2 14, 3 by root 14 and 1 by root 14. So equation of line or direction cosines of line, it comes to be plus or minus root 14. So last option, D option, plus or minus 2 by root 14 and 3 by root 14 and 1 by root 14 is the right answer, that is direction cosines of the line. So question number 11. The plane through the point 5, 2, 3 and the line x plus 1 by 2, y plus 1 by 1 and z minus 5 by 3. So we have a point and the plane. So the plane through the point, so we have plane and a point, that is right here 5, 2, 3 and the line and its vector, parallel vector is 2i plus j plus 3k, which is the parallel vector. And another point we have, that is line is lying on the plane. So point is, another point is, so that is you are getting from the equation of the line minus 1 and plus 5 is point is also on the plane. So we got a point on the plane because it is passing through the point, and another point on the plane because line is on the plane. So you just consider to form an equation, a line, a point x, y, z, general point, and you construct three vectors. So a vector and another vector we are having, that is vector parallel to the line. So we consider equation of the plane using these three vectors, that is first vector joining 5, 2, 3 and x, y, z, and second vector 5, 2, 3 and minus 1 and 5, and third vector which is our so third vector which is our 2i plus j plus 3k. So clearly volume generated by three vectors equal to 0 because all the three vectors lie on the plane. So to make an equation Just consider that is volume of the parallelepiped must be equals to 0. So this relation is required to get the equation. So what is that first vector? That is phi minus x. So better you write x minus phi. I write x minus phi, and that is one phi minus 2, and next one z minus 3. So what is the next vector? That is join 5 to 3 and minus 1 5. That is 5 minus of minus 1. Five minus 1, that is 6. That is 6, and 2 minus of minus 1, that is 3, and 3 minus 5, that is minus 2. So another vector, that is 2ij plus 3k, that is you write the components, ij components 3, 2, 1 and 3. So just to expand and get the equation, so x minus 5 into 3, so 3 into 3, 9. So clearly x minus 3 into 9, and that is plus 2, 9 plus 2, which is 11, and minus of y minus 2, y minus 2, and that is 6 into 3, 18, 18 plus, that is 4. 18 plus 4, you are getting 22 as the answer. Last one, z minus 3. Z minus 3 into 6 minus 6, that's 0, equal to 0. So you are getting 11x. So x minus 5, this is x minus 5, so 11x minus 55, and you are getting minus 22y, and you are getting plus 44, which is equals to 0. So we are getting 11x minus 22y, and you are getting minus 11, which is equals to 0. So 11, 22 minus 11, so they are common factors. So if you divide by 11, you are getting x and minus 2y and minus 1, and which is the right answer, x minus 2y and minus 1, which is the right answer or equation of plane through the point 5 to 3 and the line x plus 1 by 2, y plus 1 by 1 and z minus 5 by 3. So here is question number 12, that is plane parallel to x minus 2y plus 2z minus 5 equal to 0 and having unit distance from the origin. So consider the equation of the line x minus 2y plus 2z equals to 5 and distance from the origin. So z-axis, y-axis and x-axis, and distance from the origin to the plane. So you know Lx plus my plus nz equals to our distance d, where L, M, N are direction cosines of the normal to the plane. So you consider this same equation, x minus 2y plus 2z equals to 5, So it is parallel to plane, but it is unit distance from the plane. So you consider k as the number, so which is also a plane which is parallel to same plane. So instead of writing 5 you write k. Now these coefficients of x, y and z, they should be our direction cosines. So how to make it as direction cosines? So you know the x component or L, M, N or x component should be divided by the normal direction ratios of normal, that is 1 minus 2n plus 2. So you divide throughout by the magnitude of perpendicular vector or direction ratios of the normal, that is 1 square plus minus 2 square plus 2 square. And to make it equal, you have to divide by same value in the right hand side. So what is the denominator? That is x minus 2y plus 2z divided by root of 4 plus 4, and that is 8 plus 1, that is root 9. So this also you divide k by root 9. So make it distance as 1, that is k by root 9. So what is the value of k? K should be root 9, and root 9 is 3. So that is 3, value 3. So you substitute k by 3, you are getting x minus 2y plus 2z minus 3 equal to 0 is the equation. So k is replaced by 3. So where this is the right answer, so which has unit distance from the origin. So question number 13. The equation of the plane which is parallel to zx plane at a distance 3 units from it. So again, you have axis, that is x-axis, y-axis and z-axis. So clearly it says the plane is parallel to zx plane. So plane parallel to zx plane, so this should be parallel to zx plane. So clearly this is the distance, that is 3 units. So it is always must be y equals to, so this distance is along y-axis, so y equals to 3. So B, option B, y equal to 3 is the equation of the plane. So which is the right answer. Next, question number 14. The point of intersection of the line x plus 5 by 3, y minus 3 by minus 1 and z plus 3 by 2 with a plane 2x plus 3y plus 3z minus 8 equals to 0. So we have a line and the plane. So we have line and the plane. So you have to find the point of intersection. So clearly we want to get a general point on the line. So using this equation, suppose if you equate this is to lambda, so your x value is 3 lambda and minus 5, and y value is, so general point y value is minus lambda plus 3, and z value is 2 lambda minus 3. So these are the general point on the line. So this should satisfy the plane because this point or point of intersection is lying on the plane. So that is just to substitute the x value, y value and z value. So 2 into 3 lambda minus 5 and plus 3 times y minus lambda plus 3 and 3z, so 3 times 2 lambda minus 3 and minus 8 equals to 0. So 2 into 3 is 6 lambda minus 10 and minus 3 lambda plus 9 plus 6 lambda minus 9 minus 8 equal to 0. That is 6 lambda minus 3 lambda. So we have 9 cancels, and you are getting minus 10, minus 8 and getting minus 18, and you are getting 6 lambda, 12 lambda and minus 3, that is 9 lambda must be equals to 3 or lambda equals to 18 by 9, 18 by 9, which is equals to 2. So you got the lambda value. Now you substitute the point of intersection or general line. So 3 into 2 minus 5, that is 6 minus 5, that is 1. And next one, minus 2 plus 3, that is minus of lambda value is 2, minus 2 plus 3, that is also 1. And next one, 2 into 2, 4, 4 minus 3, because lambda is 2, 4 minus 3, that is also 1. So 1, 1, 1 is the point of intersection with line and the plane, that is 1, 1, 1. Option A is the right answer. So next one, question number 15. The value of A dot B cross C divided by B dot C cross A. So you use the simple relation A dot B cross C, which is equals to, just you replace A, B, C in cyclical order. So B dot C cross A, and which is also equals to C dot and A cross B. All the three are equal, just observe denominator. So numerator is A dot B cross C and B dot C cross A, B dot C cross A, which is also equal to A dot B cross C. So both are equal, both are equal. So just cancel it out, you are getting answer 1. So option A is the right answer. Question number 16. In three-dimensional space, the equation x square minus 5x plus 6 equals to 0 represents. So what it represents? So 4 options: a point, planes, curves, and pair of line. So to get it, you just take out the equation x square minus 5x plus 6 equals to 0. So just you factorize, you are getting x minus of 3, and you are getting minus 3 and minus 2, and x minus 2 equal to 0. So this implies x equals to minus 3 equals to 0, or x equals to 3, or x minus 2 equals to 0, or x equals to 3. So what is x equal to 3 in three-dimensional space? So x equal to 3 is a plane, and which is parallel to zy plane, and x equal to 2 is also same, parallel to the same two planes. So this equation represents two planes, that is x equals to 3 and x equals to 2. Question number 17. If the line x plus 3 by 2, y minus 4 by 3 and z plus 5 by 2, and the plane 4x minus 2y minus z equals to 1 are given, then lines are, so 4 options, lines are, line is parallel to the plane, line is perpendicular to the plane, line lies on the plane, and none of these. So what happens if line is parallel to the plane? If line is parallel to the plane, so vector parallel to the plane, B vector, and normal vector, which are perpendicular to each other. So what happens if line is perpendicular to the plane? Then normal vector, so normal vector is parallel to the line. Now just observe the parallel vector, B vector, that is vector parallel to the line, is 2y plus 3j plus 2k. So that you get from the equation of the line. So what is the normal vector? So normal vector is 4i minus 2j and minus k. Now just you find the dot product and see whether it is 0. So 2 into 4, that is 8, 3 into 6, that is minus 6, and 2 into minus 1, that is minus 2. Clearly it is 0. Dot product is 0. So normal vector is perpendicular to this parallel vector, that is parallel to the line. So line is parallel to the plane, not perpendicular plane, and line is parallel. So here is another option, line lies on the plane. So if line lies on the plane, the point that is minus 3, -3, 4 and -5 is the point which is on the line. So if line lies on the plane, this point must satisfy the equation of the plane. Just observe, that is 4 into -3 minus 2 into 4 and minus z, that is minus of -5. So whether that is equals 1, clearly it is minus 12, and you are getting 8, and it is minus 12 minus 8, and that is plus 5, and which is not equals to 1. So clearly this the term line lies on the plane fails. So line is parallel to the plane. So question number 18. The Cartesian equation of the plane which is parallel to the line. The Cartesian equation of the plane which is parallel to a line. So 4 options. So 4 planes are given, 2x plus z equals to 5, and 2x minus z equals to 1, and minus 2x plus z equal to 5, and 2x plus z equals to 1. So line is parallel to which plane? So now you take out the equation of the line. So write it in standard form, that is, r equals to a plus lambda b is our standard form. So write the first equation, which is 1i, and here 2j, and here it is 3k. And you have one parameter, that is lambda. So that is plus lambda times you are getting lambda here, that is I, and you are getting lambda here, that is minus 1, that is minus j, and you are getting here another lambda, that is minus 2k, and another parameter you are getting mu. So that is with this I, that is minus I, and no parameter mu here. So here is another parameter, that is 2k. So this line is parallel to I minus j minus 2k, and is also parallel to minus I 2k. So whether line is parallel to the line. So if line is parallel to the plane, if line is parallel to plane, then normal vector must be perpendicular to the line, or vector parallel to the line. So that means dot product is 0. Now compare which makes dot product 0. So normal vector of, so just take first one, that is 2x plus z equals to 5. So normal vector is 2i and plus k, 2i plus k. Now we compare with the 2i plus k and this one, parallel vector parallel to the line. So what is the dot product? That is component I components 2 into 1, and j component 0, and k components minus 2 into 1. So that is minus 2 into 1. Clearly this gives us answer 0. So dot product between a parallel vector of the line and the plane. So and the plane, that is our first plane. So dot product is 0. Clearly this is the right answer, which is parallel to the line. So if you want to compare with other planes, so you won't get answer as 0. So question number 19. If the foot of the perpendicular from the origin is ABC, then what is the equation of the plane? So foot of the perpendicular from the origin. So z-axis, y-axis and x-axis, and here is a plane here is a plane, and foot of the perpendicular from the origin, and this foot of the perpendicular origin is given as a comma b comma c. So these coordinates are 0 0 0, which is the coordinates of the origin. So what are the direction cosines of, or direction ratios of this perpendicular line? So you have an equation which is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0 is the equation of plane passing through x1, y1, z1 and normal vector being ai, bj plus ck. So what are the direction ratios of this line or normal vector to the plane? So clearly that is a minus 0, that is ai, and b minus 0 plus bj, and ck, which is our normal vector. So what is the equation of the plane which passes through ABC and having normal vector ABC? So using this equation, you just replace a by a, x minus a point is a plus b x minus b z minus a equals to 0. That is, if you multiply, you are getting ax and a into a square. So I write it afterwards, plus b into y, that is y. So this is y, that is by, and I write b into b square afterwards, and that is c into z. So cz and c into c square. So a square you are getting here, b square you are getting here, and c square you are getting here. So that is, if you write in the right hand side, here becomes a square plus b square plus c square. So ax by plus cz equals to a square plus b square plus c square is the right answer. So this is the B answer. So just observe, one z is missing here, z is missing here. So that is ax by plus cz is the right answer. Suppose if you consider it's a grace mark. The point on the line x minus 2 by 1, y plus 3 by minus 2 and z plus 5 by minus 2 at a distance. So distance is given, distance 6 units from the point 2 minus 3 minus 5. So you have a line and the point, and that is 2, 3, minus 5, and distance is given as 6. So just find general point on the line. So general point on the line is, suppose if you equate it to lambda, you are getting x equals to lambda plus 2, and another one point y is minus 2 lambda minus 3. General point, another point is minus 2 lambda and minus 5. So this is the general point on the line. Now you find the distance between point and the line. So that distance between point and the line is given by square root of equals to 6. So what is inside the square roots? So lambda 2 minus 2 and minus 2 lambda minus 3 and minus 2 lambda minus 5 minus 5. So that is x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. So that is the value. So lambda plus 2 minus 2. So that comes to be lambda. And here another point, that is minus 2 lambda minus 3, minus of minus 3 plus 3, that comes to be minus 2 lambda. And another one, that is minus 2 lambda minus 5, and minus of minus 5 plus 5, that comes to be 2 lambda. So if you substitute in the equation, so that is you are getting lambda square plus minus 2 lambda square and 2 lambda square. So that is 9, so 9 lambda square. So squaring both sides, you are getting 36, and that is lambda square equals to 4, or you are getting lambda equals to 2 lambda. So lambda equals to 2, just substitute in the line joining the point, that is line and the perpendicular line. So that is 2 plus 2, 4, 2 plus 2, which is comes to be 4, and minus 2 lambda minus 3, that is minus 4, and minus 3, which comes to be minus 7, and another one, that is minus 2 lambda minus 5 minus 4 minus 5, which comes to be minus 9. So 4 minus 7 minus 9, which is the right answer. Question number 21. See, if ABC, capital ABC, are the images of the point ABC on xy plane, yz plane and zx plane respectively, then the center of the triangle ABC is. Clearly, center of the triangle is given by x1, x2, x3 by 3, which is the x coordinate, and similarly you can get y coordinate and you can get z coordinate. So here ABC are the images of the point ABC. So just consider the images of the point ABC. So what is the image of this point on xy plane? So what is the image xy plane? So clearly it is A, B and minus C. A, B minus C. So what is image on yz plane? So what is the yz plane? So that is A minus B and plus C. So what is the image of this on zx plane? On zx plane. So zx plane, you are changing y coordinate. So clearly that is, this is minus on yz plane. On yz plane it is minus A plus, and on zx plane, so it is A minus B and C. So what is the center of this? Clearly it is A, x1 plus x2 plus x3 by 3. So that is A, and minus A plus A by 3. So minus A cancels, you are getting A by 3. So another point here, y1 plus y2 plus y3 by 3, which is the centroid. So minus B and plus B and minus B, you are getting B by 3. And here another one, that is minus C, C and C sum and divide by 3, you are getting C by 3. So which is centroid of the triangle which has images of A, B, C. Next one, question number 22. That is line R plus A plus lambda B will not meet on the plane R dot D. So a plane which is R dot N equals to D, and you are getting a line which is R equals to A plus lambda B. So line will not meet the plane, so only when which is parallel to the plane. So clearly it is parallel means normal vector is perpendicular to the line. That means B dot n must be 0. That is B dot n must be 0, because dot product is 0 when two vectors are perpendicular to each other. So one condition is true. So if you observe that condition is in the option A, and you won't get anywhere in any other options. So another option is this should not, the point on the line A should not satisfy the equation, that is equation of the plane. So that is A dot n must not be equals to D. So must not be equals to D. So if that equation satisfies, that means point on the line or line is on the plane. So this condition must be true and this also must be true for a line which doesn't meet your plane. So this is first option is the right answer. So question number 23. If alpha is the angle made by the line of intersection of the plane 2x plus 3y plus z equals to 1 and x plus 3y plus 2z equals to 2. So line of intersection of two planes. So you just consider two planes and another plane you take this way and normal of this line. So another one normal, so let it be n1. Another normal which is you just take it as n2 vector. So it has a normal. So what is n1? A vector which is perpendicular to the first plane, that is first equation of the plane, which is 2i plus 3j plus k. So what is another normal? So that is normal to the vector b, that is n2. I consider it as n2, that is I plus 3j plus 2k. So clearly 2, 3, 1 and 1, 3, 2 are the values. And what is the line of intersection? So line of intersection is perpendicular to both n1 vector and n2 vector. So it is clear that a vector which is perpendicular to both n1 and n2 is nothing but n1 cross n2. So n1 cross n2 is a vector I, j, k, and that is 2, 3, 1 and 1, 3, 2. So that is the cross product between n1 and n2. Clearly I equals to 6 minus 3, that is 3i. So that is 6 minus 3, 3i, and j, that is with minus sign, that is 4 minus 1. So minus 4 minus 1 minus 3i minus 3k, and k vector, that is 2 minus 3, 6 minus 3, that is equals to 3, k and j vector. So you are getting I, that is 6 minus 3, that is 3, and j 4 minus 1, that is 3, again k 6 minus 3, that is 3. So 3i, 3j, 3k is a vector which is parallel to, so which makes angle, which that is direct line of intersection makes angle alpha with positive x-axis. So what is cos alpha? So that is nothing but the angle between this and x-axis. So direction cosines of this is 3, 3, 3, that is the direction ratios, dot product with 1, 0, 0, that is direction ratios x-axis, divided by 3 square, 3 square, 3 square and 3 square, that is you are getting 27, and that is you are getting 1. So what is the numerator? That is 3 divided by root 27. Root 27 is nothing but 3 root 3, and which comes to be 1 by root 3. So 1 by root 3 is the right answer, that is angle between line of intersection of two plane and axis, x-axis. So 24th question. The value of lambda such that the line x minus 1 by 2, y minus 1 by 3 and z minus 1 by lambda is perpendicular to the plane. So what is the value of lambda? Line is perpendicular to the plane. So a line which is perpendicular to the plane. So clearly this again same idea. So normal is parallel to the line. Normal is parallel to the line. So what is the normal vector? So you are getting this normal vector that is 2I plus 3j plus 4k. And what is the parallel vector to the line? So you are getting here that is parallel vector must be 2I plus 3j plus lambda k. So this vector should be parallel. So you compare these two vectors should be parallel. So 2 equals 3 equals 4 must be equals to lambda, or lambda 4, or lambda must be equals to 4. So lambda must be equals to 4. So that line is perpendicular to the plane. So question number 25, the sum of direction cosines of z-axis. So clearly z-axis has direction cosines that is 0, 0, 1, 0, 0, 1, and they ask what is the sum of direction cosines, that is 0 plus 0 plus 1, which comes to be 1. So answer B is the right answer. So question number 26, the angle between the planes x plus 2y plus z equals 7 and 2x minus y plus z equals to 13. So direct question. So you get normal vector of first plane and normal vector of second plane. So what is the normal vector of the first plane? That is I plus 2j plus k. So using this first equation, so normal vector is 2, that is 2I minus j plus k, that is using the second equation. Clearly the angle theta, or cos of angle, cos of theta, must be equals to n dot 1. So that is I plus 2j plus k dot product with 2 minus 2I minus j and plus k divided by the magnitudes of two vectors, that is square root of 1 square plus 2 square plus 1 square, and another root, that is 2 square and plus minus 1 square plus 1 square. So clearly dot product gives us the result, that is 1 into 2, so 2, and you are getting minus 2, and you are getting plus 1. So divided by 2 square, 1 square and 1 square, that 4, 5, 6, root 6, and here it's also you are getting root 6. So that is 1 by 6. That is theta equals to cos inverse of 1 by 6. So first option is the right answer. Next one, 27th question, alpha, beta, gamma are the angles made by the line with x-axis, y-axis and z-axis. Then what is the value of sin square alpha, cos square alpha and z square alpha? So you know direction cosine L square plus m square and n square must be equals to 1. So that is nothing but cos square alpha plus cos square beta plus cos square gamma, which is equal to 1, and use the trigonometric relations, that is cos square alpha is nothing but 1 minus sin square alpha plus cos square beta is 1 minus sin square beta, and this is 1 minus sin square gamma equals to 1. So you have the relation sin square alpha, sin square beta, sin square gamma. So you are getting it as 3 minus sin square alpha equals to 1. That is in the bracket you are getting sin square alpha, sin square beta and sin square gamma. Its sum is going to be, and that is 3 minus 1 going to be 2. So the right answer is 2, which is the value of sin square alpha, cos square sine square beta and sine square gamma. So it's 28th question. If the direction ratios of the line are 6, -6 and 3, then the direction cosines are, so clearly direction ratios are 6, -6 and 3, and direction cosines are you divide by the vector and magnitude of the vector, that is 6i minus 6j and plus 3k. So that is 6 by root of 6 square plus minus 6 square plus 3 square and divided by minus 6 by same value, that is root of, and 3 by same value, that is root. So that is 6 square 36, 72 plus 9 could be 81. So 6 by root of 81, 36, 72 plus 9, so 81. So 81 comes to be 6 by 9, and 6 by 9 is nothing but our 2 by 3. So clearly 2 by 3 is here, 2 by 3 is here, and next one minus 6 by, we are getting 9, so minus 2 by 3, and last one 3 by 9, you are getting 1 by 3. So first one is the right answer, that is direction cosines. So question number 29. If the vertices of the triangle are A -2, 3, -6 and -4, 4, 9 and 0, 5, 8, then the direction cosines of the median through B. So consider a triangle, that is A, B and C. So values of A are -2, 3 and 6, and B, which is -4, 4, 9 and C is 0, 5, 8. So we want to direct cosines of median through B. So through B, so this must be our midpoint M. So what are the coordinates of point M? That is -2, 3, 6, point A, and point C is 0, 5, 8. So -2 plus 0 by 2, that is -1. And next point 5 plus 3, that is 8 by 2, which is comes to be 4. And 6 plus 8, that is 14 by 2, which comes to be 7. So this is the midpoint B. So we want to find direction cosines of the median through B. So that is MB. So what are the direction cosines? So M is this one point, M is this one. So direction cosines are just get the difference, -1, minus of minus plus 4. So that is you are getting direction ratios, and 4 minus 4, that is 0, 4 minus 4, 0, and 7 minus 9, that is -2. So these are the direction ratios. So you are getting 3, 0 and -2. So -1 minus 4, that is plus 3, and 4 minus 4, 0, and 7 minus 9, which is 2. So these are direction ratios. So what are the direction cosines? So just you have to divide by its magnitude, that is magnitude of the vector, that is 3 square plus 0 square plus -2 square. So what is 3 square, 0 square, -2 square, 9 plus 4. So you are getting 13, root 13. So that is 3 by root 13. And you are getting 0. Another one is -2 by root 13. So clearly, first one 3 by root 13, 0, and -2 by root 13 is the direction ratios of the median. So last question, that is question number 30. The distance of the point 1, 2, 3 from the plane x minus 3y plus 2z plus 13 equal to 0. So consider the equation x minus 3y plus 2z plus 13 equals to 0. And point. So what is the point? So point is 1, 2, 3. Clearly, just substitute in the formula. So distance is equals to, that is ax1 plus by1 plus cz1 plus d equals 0. So that is d. So x, that is 1 and minus 3 into our point, that is 2, and 2z, 2 times z, which is 3 plus 13 divided by square root of a square, b square, c square. So a is the x component and b is our y component and z component. That is 1 square plus minus 3 square and 2 square. It comes to be, so answer is 1 and minus 6 and plus 6 plus 13 divided by 1 square, that is 1, 9 plus 1 plus root 14. So 14 by root 14, which comes to be root 14. So option number first, that is A, is the answer to the 30th question. So with this last question, we will end our session. So good luck to all. Thank you.